Okay, we're looking at question 3.2L. It says that a airplane drops off its cargo, and it goes, when it drops off its cargo, it's flying this way, and then as it drops it, there's no air resistance. They will both land. They'll both be the same. They'll both land. They'll both be at the same position from each other. So like one doesn't get ahead of the other. And this is really only true when there's no air resistance. So when they both, when the package or the crate hits the ground, the airplane will be directly above it. Let's take a look at some of our givens. We had to convert in the beginning. It says you're 10 kilometers in the air. You have to convert that, and it comes out to be 10,000. So the dy is equal to negative 10,000. And this is how you convert from 750 kilometers per hour is that many meters per second, which I put here. So the first question wants to know, for part A, how much time does it take for it to fall? So we just want to solve for t. Your best bet is to use the vertical column to solve for time. Step 2, we have VIY, AY, dy. So best bet to use is dy is equal to VIYT plus 1/2 AYT squared. That gets canceled out because it's 0. So we'll have a different answer here for this part. That's going to be our code. So that's going to be equal to 1/2 times negative 9.8 t squared. That's actually our code converted. So from part A. All right. So we have. Let's just solve for time. Time is going to be equal to negative 10,000. Divide that by 1/2. Divide that by negative 9.8. Get the square root of that answer. We get that. I'm going to store this as alpha A. So t is equal to alpha A, which goes up here. Now for part B, I'm sorry, this wasn't part A. This is for part D. Now for part E, it wants to know, actually, I'm sorry. This was part C. Part D wants us to figure out what is the horizontal distance of the crate after the point that it was released. So we're going to do step number 1, solve for dx. Step 2, we have ax, we have bix, and we also have t. We can use dx is equal to bixt plus 1/2 ax t squared. That's equal to 0, the ax. Step 4, dx is equal to, it converts to 208.3 repeating, there's the VIX, times alpha A. So it would look like this. It is, just take this answer and multiply by 208.3 repeating, and just write 3 a bunch of times. So, we'll make sure that it's at least about 8 places out. And enter, and that's our answer. So that's the total dx, which is about 9411.5, so on and so forth. Now for part E, it wants to know how far is the crate from the aircraft when the crate hits the ground, assuming that the plane continues to fly at the same constant velocity. There's really no work for that one. The distance from here to here is still the same. It's negative 10,000 from here down, but the question wants to know how far, so that's a scalar. So for me, the answer would just be 10,000. Right, so that'll be different for everyone based on your code.